By now, I guess. This is the second long day. I know we're coming to the end of the day, and we want to do a couple of few things just to give you also a little bit of a, an idea what GIMI is all about. I want to show a couple slides, and then actually my students Divya and Cong are going to come and going to show you two different cases. Number one is we want to show GIMI running GIMI experiment on top of GENI, and also use that as an opportunity to explain a little bit what post-boot scripts are and how we use them to kind of set an image up to make it measurement ready. I'll try to get this going here, and then we're gonna show you a little bit more elaborate measurement where we kind of we have a video client, we do some adaptive streaming, and you can look at the data and this kind of things that are happening there. So I also would like to do this as interactive as possible, since there's still the kind of word tutorial in these sessions here. So ask any questions you have whenever you feel you have a question. It would be nice to keep this a lively session if possible. So is there something cut off? It's kind of hard to see. Oh, I see. I'm getting tired of it right in front of me here. So excuse me. So we talked about this. Before I've shown this morning about the experimental life cycle. We can go quickly through this. Here we're dealing basically for today. We're going to deal with simple topologies, repeatable experiments. We can maybe show you guys how we can run an experiment over and over again, and then ability to monitor and actually document an experiment. And then there's the whole stuff of analyzing your data, but that's totally up to you. I cannot help you with that. The smart work and hard work you have to do in the end yourself, right? So in our case, it's a little bit more around this. Talked about this morning, the experiment cycle, about planning experiment, preparing experiment, and executing experiment, and also being able to kind of document, to follow along with your experiment in terms of what's going on. That's kind of what we talk about, the experiment cycle. And I had this joke this morning about this is a successful experiment cycle. And what in GIMI really helps us with doing that is actually a tool we call LabWiki, which has these three panes. And let me just walk over here. Will you lose audio when I walk over there? Oh, okay. Mike, there's a mic. So let's do it this way. So he has audio on the video. I will just point a little bit at this. Is actually not turned on. Okay. So this kind of, when you see the cycle, this is kind of repeated here, where you have like a plan, a prepare, and then an executed thing, as we call it. So it kind of helps you going along with this, where you have your wiki page. You can actually look, there's images in there. You can describe what you're doing in your experiment. Then you have your preparing. This is where we have these scriptable experiments, where you can actually define what's happening in your experiment, when a node starts sending stuff, when a node starts receiving stuff, all kinds of weird and wild things you can dream of. You can actually remotely execute just commands at a node, for example. So we have one example we didn't get to yesterday, where we can actually set route configurations on a node, right, and all these kind of things. And then where you can actually finally go over and then just start your experiment. To make clear, one thing you don't see here yet is actually what has to happen before we can actually get to this point. Just keep you awake. I'm asking a couple questions here. I'm a professor, so I do this all the time. Create a slice. Hey. So what? At least someone's paying attention. That's great. So you have to create a slice, right? So with your preferred tool, Flux or Flag or whatever, we're agnostic to that. You have to create a slice, and remember the slice name. And then when you go, well, sure that later. When you start your experiment, you have that there, right? So slice has to be created beforehand, and then you can actually start using this tool. We're thinking carefully about maybe integrating this a little bit more, but that's probably one important thing. You have that already in the desktop, so that's somewhat different in our case, right? And so then you can execute experiment, and then you'll actually be able, as I showed this morning, to see the graphs. You can observe your experiment. You can actually document the results. The results get also stored. They get stored into iRods. And then you can use these results for any kind of analysis, whatever you want to do with it, right? So that's kind of what's happening. Let me actually stop here and see if you have any questions about this kind of conceptual part of what we're doing here. Okay. So, so what I want to show you, you know what? Sorry, I just want to make sure that I opened the right. Oh yeah. Let me just jump here. So how the interaction is here is actually, and don't look at this part down here at the moment. So when you have brought up your slice, and that is something important, similar, I guess, in your case, that you have to have certain components on the image in your VM you're bringing up, right, to perform a measurement, right? So what we have actually is we have to have OMF and OML clients running on these images, right? If that's not there, you cannot perform a measurement, right? And so why do we need this? Because what we have so-called resource controllers and measurement libraries or measurement points that run on these nodes of your slice. So here's just an example. Think of this. This is a slice in InstaGenie or ExoGenie for an experiment, right? And so these things have to come up. And why do they have to come up? Oh, sorry, now I have to walk back and forth all the time. Why do they have to come up is for different reasons. And that is because on one side, we're using an XMPP messaging service, right? And the resource controller, when the machine comes up, we do a little change. When we talk about post-boot script, you'll understand that better. They go back and say, "Hi, XMPP server, we are all part of that experiment," right? And we'll see the way you do this is you specify a certain slice name. They all come back with, we are part of that slice. And then your experiment controller, the ECU is actually running on that node also here, comes also up and registers with the XMPP server and says, "I'm also part of that slice," so to speak, right? And so that's kind of how you kind of establish a communication mechanism between the different components. That's how they talk to each other, so to speak, signal each other. And so you have that part going. So that's why you need that's part of the resource controller. The resource controller does a couple more things, but that's kind of important to understand the communication mechanisms. And then the other part is actually, let me just stump to that, it's the data collection. So that's where you need the measurement points. We're using OML, the orbit measurement library, where then when you have an OMLified application, right, you send the data back to the OML server. It then gets transferred into iRods, and then from kind of any client, any kind of iRods client, you can actually get the data out for your analysis. So that's why you need these components on your images, right? So if you bring up a slice, no matter if it's on InstaGenie or ExoGenie, and you don't have these components up and running, you cannot perform a measurement in our case, right? That's important. And what you also need is for certain applications, you have to have these OMLified applications. So right, a regular ping wouldn't work, right? Because when you run a ping on a slice, where's your output going to? The screen, right? But if it goes to the screen, it's not going to the OML server. So there's an OMLified ping available you can use that has a wraparound. It captures that output and then sends it over to the OML server, right? No, it's, yeah, we're trying to make it a standard. So, so the orbit measurement library, it's part of the orbit measurement, it's part of this, there's a kind of an interplay between OMF, the orbit measurement framework, and the orbit measurement library. And the orbit, I would say OML is the part of that takes care of the measurement data, so to speak, while OMF is more the control, right? So you have a control layer and you have a data layer. And so OMF is more the control layer, and OML is more the data layer, so to speak. And but there's if you go to the mytestbed.net, right? There's a great documentation on both, so you can find out more things about that. With respect to time, I'm sorry, but we can talk offline if you have more questions about that. I just want to move forward. We still have to do two quick demos. So I explained to you that we have to have things on the nodes running, right? And so something that Ilya introduced, or Ilya and his team introduced in ExoGenie is actually this wonderful tool of post-boot scripts. And I don't know what the story in InstaGenie is. Was that there already, or did we have to do something to make post-boot scripts working on there also? I totally forgot. It's working now, but I don't know why it's working. So they have a similar mechanism. So what you have to think of is is, and you can actually specify that through your RSpec, right? That when your machine boots, right after the boot, a certain a script is executed. You can just think of it like a, I'm blanking here. Victor, what's the name for the script? Speed? Velocity, not speed, velocity. I'm almost right. It's really getting late for me. So the velocity. So it's kind of, I think of it almost like a bash script. Then that's executed, right? But you have certain variables. So you can. This is an example of a post-boot script here, right? So and what you do here is actually, this is a post-boot script example for GENI, right? So that's why it looks a little bit different than what you see. But for example, we need, I told you, right, we identify, we communicate, so the unique identifier for our XMPP communication is the slice name, right? So what we do here is actually, we extract that slice name out of this variable, right? Put it in here, and then later, when we start the resource controller down here, right, there's a little config file for the resource controller, so we pass that in here. And then we start the resource controller with that slice name, right? And so that's pretty nice because you don't have to kind of, configure everything. You don't have to bring up your slice and then go into every node and reconfigure that to have that all set up, because you usually don't, at the beginning, that completely automates it based on the slice name, and so that's something. A way you can kind of automate your measurement, and you don't have to touch things, so it comes up automatically, totally, completely. You can even do things like just curl. So here we're getting a couple updates into it. Cong, when he does his demo, for example, since he brings up also a video server, right? He does a very long curl to get this video into that VM that's coming up, right? So you can just get stuff off the web. You can put stuff on a web server if you need certain modules and stuff like this, and then just as automated. So that helps you with kind of, configuring your single nodes and getting that up. So I think that's a very nice tool to kind of, have things tailored to your measurement, so to speak. And with that, I would like to hand over to Divya, who's going to show us actually how you, how run a measurement, and do that actually on GENI in this case. So Divya is going right now through the experimental portal, right? You guys have hopefully all seen that before. And she already has been here with respect to time. We don't want to keep you hostage here until 7 p.m. or something like this. She has already brought a slice up. Here we'll just show the slice in flag. And it should be here in a moment. This is a simple 5-node topology here we have set up, and I'm just going to do some, something in this case here between the different slices, different nodes. Sorry. Should be here in a second. Unfortunately, she had it all brought up on her laptop already. So sorry for that.
Okay, I need to quickly just add you as a member because I'm logged in as myself, and if we need to SSH, we need my certificate. So I'm just going to. Okay. Download.
You know what? My keys don't work. Just don't do it. We ran into this problem yesterday. So
Okay.
Just do it.
No, I cannot SSH into them without the keys.
Yeah.
So.
Yeah, but remember that my keys didn't work yesterday.
Okay.
You need to see the SSH, or you just...
No, you just have to believe us that it's working.
Okay. Okay, so.
She can still SSH.
taking a moment to bring up the slice. Once that's done, we can. We've used for earlier GIMI demos, but this time it's an GENI. So it's ready, and if I just move over to
Good. This is the nectar one. Make sure.
this is the nectar one. So okay. So it's just taking a moment to load here.
You might want to look out and look in again because you're looking at this.
Oh, yes, that's right. Okay, so now I'm going to log in using my GENI ID. And let's see. Yes, it's
okay.
okay. So here we have the ping all script where it's going to ping all the interfaces of the nodes. The same topology that we saw in the previous slides. And I just drag it and drop it here, and the slice name that I will give here is the same slice name that I used to reserve resources on FLAC. Okay. Then
And you might actually bring up something on the wiki so you can actually
okay,
document the
sure.
graph.
So I can bring this up and just move the graph over to here when it's ready.
So here actually for you know when you if you want when you want to do this yourself, we have as in the Gemini case we have tutorial pages on there. But also what we have done is here in the wiki we have actually put the tutorial instructions in the wiki, so you have it also right there. It makes it a little bit more convenient. Oh, sorry. So here, it doesn't go on the tape if I don't speak into a microphone. Here you can, so what did I say? We have general tutorial instructions on the GENI wiki, but we also copied the tutorial instructions in the lab wiki part, in the plan part, so you can just look at it right there. You don't have to switch back and forth and get the instructions from there.
I've clicked on start now and just waiting for it to talk to the nodes. Okay, so it's talking to the nodes, and we can now see the graph here. So let me just pull it over to the left so it's clearer.
Give it more space.
Yeah, it's just okay. This one?
No, on the blue one, the corner.
Okay.
That's 11.
Okay. No, F11 didn't do it. Okay.
See the blank plan panel here? There's actually icon here.
That,
Mhm.
and you can expand it. Here we go.
Okay. Yeah, now it's better.
No.
What's nice here is actually so two things that are interesting is on the right hand side in the execute, you can actually see the log data for your experiment, so you can actually see what's happening, right? If the communication with the nodes is going fine, when it's running, when it's stopped, and all this, so you can observe the execution of your experiment. And then I always find it nice that you can here see a nice open flow behavior, right? Because this is not. Oh, so this is also. How's this an InstaGenie actually? Why is the first ping taking so long here? Is it also open flow? Does anyone know that? I'm just wondering because in ExaGenie we know you built your slices based on open flow flows, and so the first ping is always very long because it sends the first packet to the controller and has to come back. Don't know why the ping here is, why the first ping is here so long. But this would be something now where you can start your analysis and put your smarts in. Is why is this first ping taking so long? What's happening there? And you can analyze that. Gonna run over and find someone like Rob and maybe ask them. So this is just a basic, relatively simple experiment just to show you the functionality here. that we have for running that. With the dump button, you can then archive that in iRods when we have that online. And there was one more thing I wanted to say. I forgot. In general, showing that, yesterday in the tutorial we did this all on GENI. Today in the demo we're just doing this on GENI just to show you that it actually works on 2 different racks. Okay? Thank you. Divya,
Thank
Cong, you want to come up and just do yours? And Cong has a Mac, so it should be a little bit easier. so bear with us for one more demo, and then you can all go off and relax. Is it? Is this printable? No, I don't. It's. I don't. That's a good question, actually. I don't. Yeah.
Actually, that's a kind of a future feature. Like you can actually save it and actually generate PDF out of it straight away.
It's coming. GEC20. Well, we have to have some reasons for you guys to come back, right? So.
Yeah, exactly.
But at some point it has to become static, correct?
Right. That's true. When we've got all the data from the database,
Right.
so all the data show on the graph.
So in theory, you could print that frame and export a PDF at least in the interim right now.
Yeah, of course, but it's actually.
And it's a workaround to get you through until there's a native export to PDF function.
Yeah, absolutely.
Does that work for you? Okay.
I wasn't sure if the print function was fancy JavaScript.
Yeah.
Okay, so this seems to be crowded, but anyway. Yeah. Professor, you want to talk about the?
Yeah. Let me talk.
Sure.
You can drive. And if I forget something, please add it.
All right.
So for this case, actually.
Into the mic, please, Mike.
Oh. Thank you. In this case, what we're doing here is we're using GENI again, just to add a little bit more to the confusion today. And so this is the slice Cong has set up. This looks a little complicated here. We're actually using flukes here. Graph layout. Well, which one? What?
Either of the other two.
Any of the other two.
Okay.
So and we get this feedback from the implementer of it. So what we've done here is actually, and that's kind of nice here because you actually see what's really going on in the background here. Is a what is that 8-node slice? And what we see is here on one side we have VMs in the right. We have it in the University of Houston rack, right?
Yes.
And then on this side we have actually slices in your hometown, down at Rancy. So we actually have, this is all short distance links, and then we have really some long distance kind of, stitching actually happening in this case here between the same substrate here going on. And so we just wanted to show you, to give a little bit of an idea what you can do, kind of, how more elaborate slices you can set up. And where's your server running right now? Where's the web server running? Which node? Node 0?
Node 0.
Yeah. So node 0 up here, we have a web server running, has a little video stored on it. And what we want to show you here is, and this one is the client?
Yeah.
Okay, and this one is the client. And so what we do here is we run actually OVS, Open Virtual Switch, on these nodes here, right? We have a little script in the background that switches the flow path between just going directly and going up and down here. And so what we're doing is actually, Cong has unfortunately, because we don't have a layer 2 connection here in this room, we did it last night at the demo floor, he has a VLC client that is dash enabled, so dynamic adaptive streaming over HTTP. And but since we cannot see anything, what we have done is we have it instrumentized. So we have written these OML wrappers around it, and we can actually measure certain variables, so to speak, in terms of help me out again here. What are we measuring?
The
Buffer,
yeah,
buffer status, buffer size, and buffer fill rate, so to speak,
yeah,
and
bit rate
and the bit
status.
rate, right? And so, so this is just a slice. So if you go over to LabWiki now, we'll see where we can actually see some interesting parts here. So again, you know, you can think now Cong is a very good student. He's like meticulously taking all his notes about this experiment. He's describing the slides and all the stuff he's doing here. Just saying that here, right? So and then he has his he's a good student. I should confirm that. But and then he has written his experiment script with respect to time. You know, there's certain things. You know, see, this is a little bit more elaborate than what we saw this morning when Shufeng showed his for the OML load balancer. But if you want to learn more about it, also on mytestbed.net, there's a really good documentation on that. Or ask this guy; he can give you more specific information on this experiment script here. Go all the way down, please, for a moment. And go, yeah. And here he actually he defines the graph. So when you talk, this is where you can actually customize your graph, right? How do you want to have your graph look like? What do you want to show? What variables you want to show like? And what's happening here is it actually goes to that. You know, I've shown you where the OML data comes all together in that database, and it queries that database and pulls it back, and then displays it, and that's how you can observe that. So he has his experiment here. We have a slice already. So Cong, when you fill all this stuff out over there, or just drag it over again. Give it a name. Again, here you got to make sure that you give it the correct slice name as you did when you used Flukes to set up the slice. Set the graph to true, and then your tremor controller is running in the background.
1 second, let me check. Okay. No, it's not running. Okay.
That's running.
Yeah, it's running.
Okay, excellent. Good. So this is the little, you know, we have a little open flow controller that's running in the background that's changing these flows just periodically, just for the demo here. You can, you know, if you're a good open flow control expert, you can do all kinds of fancy things you want to do based on that. Okay, go ahead and just, you know, shoot it off. So again, go a little bit down here. Yeah, so go back here. So here you can actually now see what's happening, right? So the experiment script, the experiment is starting, and you can actually also sometimes see if something goes wrong. We know if you cannot reach a node, you can at least observe that there's something wrong and kind of get some information and hopefully helps you to debug it. And now here you see you have the graph starting. And so let me talk about this for a moment. So I have to go a little bit into the application, what's happening here. So when you do adaptive streaming, the idea is actually that you adapt the goal of adaptive video streaming is actually, you know, to still be able to play a video although your bandwidth goes down, for example, right? So if you don't have adaptive streaming, what happens is if your bandwidth goes down extremely, is your buffer dries out. And we see this really often with YouTube, for example, these days, right, where in the middle, sometimes the bandwidth goes down and it stops and you get the stupid clock turning again instead of your wonderful video finishing, right? Now, what adaptive streaming is, you have different copies of that video and you can switch to a lower bandwidth, which, you know, has quality impairments for sure, but you can at least continue watching this video. Now, what you could see here, but what Cong is showing you here is actually the decision rate. And so the decision rate is actually something that tells you when to switch to a different quality version of the video. This is all what we're observing at this VLC client, right? And if you go to the next graph, if you go scroll down, is that the buffer?
Yeah.
You see the buffer percentage, right? We'll have to see when it switch over if we can really demonstrate this right now. But this is one thing where you could actually create a really interesting experiment to make sure that the implementation of that client is correct by saying, look, no matter what's happening with the bandwidth, right, my buffer rate should kind of, you know, always stay as high as possible, because that's the goal of adaptive streaming, right? You can change your quality, but you always want to have as much in your buffer as possible to not dry out and go to this point of stopping. Well, if you have really severe bandwidth reduction, then that's one thing that's happening. So this is kind of where we wanted to give you an impression where you can actually, you know, with instrumentizing an application, you can run experiments and then really, you know, analyze what's going on with your experiments. See of now you could actually go, you know, this would be a little bit of work. You could, you know, this is the VLC client, and you could analyze that. You could actually take Chrome has another Dash client, for example. Can we instrumentize the Chrome client? It's all actually open source, so we should be able to do that, right? And then we could run it again in the same environment under the same conditions, and could see how the adaptive streaming, the adaptation works with Chrome, for example. Is it the same, right? Or is it better, or is it worse, and so this kind of things. And we can nicely now show that what's happening live. Cong, one thing I'm actually missing here at the moment is when we're switching the paths. Do we see that somewhere over here? Should we see?
Yeah, we switch the path every 10 seconds. So
Okay.
something like we switch the path here, and then it goes down. But after adapting the bitrate, and the bitrate will go up again. And but
But that's
after
the
some
decision.
time,
Is that the bitrate or is that the decision rate?
this is the decision rate.
Right.
So it's like it will try to find the lowest the lowest bit rate according to this decision rate. So it's like greater than the decision rate, but that's the lowest version of the available bit rate.
the
Not
lowest
sure.
that you can get across over the available bandwidth at the
Yes.
moment. Okay.
So
Okay.
does average over time sort of converge?
I think so. Yeah. But that's now where you can actually, where the interesting work starts, right? You can look at this kind of algorithms, what happens to it. Now what would be nice is, you just throw an iPerf in and run some competing traffic over it, what's happening with this. You can actually, what's nice with that is actually, you have these description files. If you go back to the topology again, check my time here. You go back to the topology, you can actually store the same version of the video at different locations, right? So you can flip over to different locations. So even if a bandwidth goes down, or you have some bandwidth reduction here, can you switch over to another source? Well, how fast does it recover from that? What are the implications to your adaptation algorithm and so on?
Last week you have means to loop for, say, if I wanted to run iPerf at one level of bandwidth and then another level of bandwidth, and then correct that in parallel with the decision rate.
Yes,
Yep.
we have done that actually. Do you have this? Can you go back to Lab Wiki? Do you have the GEC17 tutorials in here?
Not very sure.
No, it doesn't. No, you don't have step 1, 2, 3, 4 in there, right?
Yeah, I have step 1.
Okay. Can you go to step 4?
Okay.
Right.
I think I have changed that. So
Oh, come. So
That won't
I
work.
could show you later on an example where we run a loop. That was not iPerf, that was OTG, right? So
Yes,
there's
traffic
also traffic
generator.
generator, which would actually is actually the better tool for that, right? And what we did for the traffic generators, we increased the packet size. So we did one run with that kind of size packets, another one with that kind of size packets, and we looked at the throughput. If packet size has any impact on your throughput, right? And that's I think along the lines of what you were asking. Can we do that, right? So you can run one experiment, and then your competing traffic you can run over different parameters. And sure, you can plot that in addition.
I was going to say plotting the competing traffic in addition to the decision rate.
Yes, yes. You can can you go back to that experiment script?
Here, you mean?
The prepare one, yeah.
Okay.
But go back. Oh, this is VLC. Go all the way down. So here you see he defines two graphs, right? Go a little bit further down, Cong, if you don't mind.
That was commented. So
Oh, so how do you do the second? Where's the second graph?
these
Here,
are
one,
the,
two.
the two
These are the
graphs.
two graphs, and then you can just define a third graph.
Yes.
I don't know, Jack, is there any limit on graphs? There's definitely kind of space limit here of what you can see, but yeah, you have to buy a bigger screen at some point. in
And
time.
then overlay both of those on the same graph, or no? You have to have separate
Yeah,
graphs.
no, you can have that in the same graph. We have not. Oh, you've seen that this morning with Shu Feng's a plenary demo where he had two graphs in one plot. No, it's all good questions. Don't worry.
What's the relationship between the code window and the git repo?
So very good question. So that's where your scripts are stored, right? So you have it we have it in a Git repo. We also, unfortunately, we had a little bit of a hardware issue with iRods just before GC. So we also have the functionality to have that all stored in iRods, right? So you can your scripts.
So we actually have multiple repo types.
Yeah.
So it could be Git, it could be no code directory, and also could be iOS.
And so This is an editor as well for code?
Yeah.
So then when you save,
You work when you come in, you get.
wow, that's nice.
Okay, I think, Cong, am I missing something really important? Most likely.
I think
Well,
that's all.
That's
That
all.
should be
But,
good.
you know, any questions, guys? Okay, hey. Okay, time for beer. Let's go. Thank you very much.